All right, hi everyone. We're down to the last part of solving equations by elimination. This time, the last part is about um, solving simultaneous linear equations with fractions. So the steps that we have here is that first we have to find the LCD of the denominators so that we could avoid or we can avoid solving problems that involves fractions. So what we're going to do here is we're going to make a new equation which is similar to this one that would give us whole numbers for the answers for the equation itself. So let's say, for example, it says here, we are going to find the LCD of the denominators that we have. So LCD means the least common, the LCM of the denominators. So here, we can see the denominators are 3 and 9. So if we are going to find the LCD of 3 and 9, okay, we will know that the LCD is equivalent to 9. So this means that this whole particular equation has to be multiplied to 9 so that a new equation would come out which will give us whole numbers or exact values for the terms. So let's say, for example, if we are going to convert 2 over 3x, so we cancel out the 3 and the 9. So there will be 3 here, and that 3 will be multiplied to the whole number. So that the numerator, I mean, so that is going to give us 6x. All right. The next one is we cancel out this 9, and this will leave us with a value of minus 9y. And this one now will give us an answer of 54. So the same thing that you guys are going to apply if you encounter a single fraction term for the equation. So what you're going to imagine is that these whole numbers that we have will have a denominator of 1, meaning to say that the LCM of these, the LCD of these particular values is 3. So that means we are going to multiply the whole equation by 3, and this is how it will look like after. So we multiply 3 and x, so this is going to give us 3x. We cancel out the denominators here, and this is going to give us minus y. Okay. And then this is going to give us 18. And as you notice, guys, if you pay attention to this particular calculation, you will see that both terms are having the same signs, which means that if you are going to do this, it would be highly suggested that the next equation has to be multiplied with negative instead. So we will now be having a negative or different values for this one, or you can just simply rewrite everything with a different symbol. So let's say 6x minus y is equivalent to 54. And then this 3x will now become minus 3x since we multiply the whole equation by negative 1. So this is now going to be minus 3x. Okay, and then plus y is equivalent to 18. So in here, you will now be able to solve a particular value, so that this would mean that the y is going to be eliminated, and this is going to give us a calculation of 3x is equivalent to the ones that we have here. Okay, notice that this one should be a negative 18, and when we solve for that, we are going to get an answer of 36, wherein the value of the x will now be equivalent to 12. Okay. So the same thing to what you're going to apply for you to get the value of y. All you need to do is to substitute these particular values in the equation. So some of you might be thinking, Mr. Ronald, where are we going to put the x here in this equation, here or here? So for that one, you can choose whichever you guys want to put it, as long as you solve for the value of y. So let's say, for example, I would like to put this in the fourth equation that I have. So I will just write here equation number 4. And I will be having this 3 times the value of x, which is 12, minus y is equivalent to 18. So this is going to be 36 minus y is 18. So minus y is equivalent to 18 minus 36. And we know that minus y is equivalent to minus 18. And we cancel out this negative for us to get the value of y as equivalent to 18. So in here, we will now state that the solution is x is equivalent to 12 and the y is equivalent to 18. Okay. Now this time, guys, I would like you to pause this particular video and try this one. And just a clue that you guys need to convert this into an improper fraction as 7.5. Okay, pause this. So now, as you can see, we are going to state this, and we are going to change these equations in such a way that we will be having whole numbers instead for the terms. So if you guys are going to get this one, so we are going to get the LCD of 2 and 3, and we know that the LCD of 2 and 3 is 6. So that means we are going to multiply both equations by 6. So this one will give us 3x, and this one will give us minus 2y, and this one will give us 24. Okay, so in this one, we see that the denominators are 5, 6, and 2. So this would mean that the denominator, the LCD of these denominators is said to be 30. However, just like what we did here, so that we will not be having multiple changes, I want you guys to be particular with the signs of each of the terms, pair terms. So let's say for the x, you can see that they're both positive. For the y's, you can see that they're both negative, which means that for us to get to the elimination right away, what we need to do is to make this multiplier a negative value. So instead of 30, we are now going to have it as negative 30. So in this case, this will give us negative 6 times 2 will give us negative 12x. And then this one is negative 30 divided by 6 is going to be negative 5 times y is plus 5y. And then this one is going to be negative 30 divided by this 15. Negative 15 times 7 is going to give us 105. Okay, and negative 105 to be exact. Okay, let me just negative 105. All right. So now what you're going to notice, if you're going to ask how we got 105, so 105 is equivalent to 15 times 7. Okay, so that's how we get it. And since the sign of this one is negative, then it becomes a negative one. Now, if you're going to take a look at these particular values, you will notice that none of them ended up to a particular term that we can eliminate. So that means we have to reprocess this again in such a way that we can eliminate a certain value. Now, in this particular part, I want you to pay attention to the x and the y. So as you can see here, if I make this y similar or making the LCD, okay, the same with the absolute value, then you will see the LCM, the LCM, you will see that you have to make these two equations change. However, if you are going to focus on the x, you will notice that you can easily eliminate the x by simply multiplying it by 4. Okay, so as soon as we multiply this by 4, this equation will now give us a calculation of 12x minus 8y is equivalent to 96. And then minus 12x, the next equation at the bottom, will now give us minus 12x plus 5y is equivalent to 105 with a negative. Okay. So in here, you can see that we can cancel these particular values, and this will end up with negative 3y is equivalent to 9, negative 9, which will give us a value of your y as equivalent to 3. So we cancel this negative and we process 9 divided by 3, which is going to give you a 3 for the value of y. Now, the same thing is what you're going to apply if you want to solve for the value of x. All you need to do is to substitute this particular answer that you acquire. So let's say, for example, if I'm going to use this equation, 3x, this is equation number 3. I'm going to use 3x minus 2 times the value of y, which is 3. It's said to be equivalent to 24. Okay, so this is going to be 3x minus 6 is equivalent to 24. And then 3x is now equivalent to 30, wherein the value of x is equivalent to 10. So from here, you will now see that the solution is x is equivalent to 10 and the y is equivalent to 3. Okay. All right. So I hope you guys were able to get this one. And now we're going to move on to solving by substitution. So solving by substitution means we're going to change one of the equations so that we can substitute it to the other one. Okay. So in here, it says making one equation in terms of x or y. So what do I mean by that? So in this way, what you need to do is to look for a variable that is in the unit of 1. So for example, we have this y here. So this particular equation will now be changed in such a way that it will be equivalent to y. So here we can say that this is y is equivalent to 57 minus 4x. Okay. So if y is equivalent to 57 minus 4x, then what we need to do is to substitute that particular value to the equation number 1. So equation number 1 tells us that we have 7x minus 2y, wherein the value of the y will be substituted here. So we will now have 57 minus 4x is equivalent to 21. So from here, you will now see that you can distribute this negative 2 to each and one of the terms inside the grouping symbol. So what you're going to do here now is you're going to distribute it and make the calculation. So this will give us 7x minus minus 114 plus 4x is equivalent to 21. Okay, so if we combine the values of the x, this will now give us 11x, and 21 plus 114 will now give us 135, which means that the value of the x is now equivalent to 9. Okay, so in this case, after we get the value of the x, all we need to do is to solve for the value of y. Now, which equation are we going to use in terms of this case? Now, you notice that when we put equation number 2 in an equation equivalent to y, you can see that it will give us an easier way to find the value of y in that particular equation. So all we need to do is to just substitute that value of x to what we see in the particular question. So this is going to be 4 times 9, wherein 9 is the value of x that we got. So let me just put an arrow here. So that is the x. So if we calculate this, this is going to be 57 minus 36. And we will now see that y is now equivalent to 21. So meaning to say in here, the solution says that x is equivalent to 9 and y is equivalent to 21. Okay. Now, please pause this video, and I want you guys to try this following the same format. All right, so let's assume that you guys calculated this. So let's just solve for this particular question. Okay, so again, for this particular question, what we're gonna do is to make an equation in terms of x or in terms of y. So in my case, I would write this down as an equation wherein the x is equivalent to 3y minus 7. Okay, so we achieve that when we put this x here, and the 7 will go here to this side. And as soon as we get this equation, what we need to do next is to substitute it to equation number 2. So equation number 2 tells that we have 2 times the value of x, which is 3y minus 7, plus 3y is equivalent to 4. Okay, so from here, what we now do is distribute these values. So this is going to give us 6y minus 14 plus 3y is equivalent to 4. So we solve for the values of y, which is equivalent to 9y minus 14 is equivalent to 4, and 9y is equivalent to 18. So that would give us y as equivalent to 2. Now from here, you will also notice that as soon as we get this value of y, what we need to do next is to substitute this to the x that we have. Okay, so from here, we are now going to substitute it to the x. So x is now equivalent to, let's just put a line so that you guys will understand which equation we use. So from here, x is equivalent to 3 times the value of y, which is 2, minus 7. So as you can see here, we just substituted this value here so that we can get the value of x. So this is going to be calculated as 6 minus 7, wherein the x is equivalent to negative 1. So if x is equivalent to negative 1, then that would mean that the solution that you guys will have is x is equivalent to negative 1 and y is equivalent to 2. All right. Okay, so that's how it works. Okay, so the next one tells us that we have to make the numerical, it says here, making one of the equations in terms of x and y. And notice that all the equations have numerical coefficients. So what are we going to do if we encounter a problem like this? Okay. So in this case, this would mean that we have two options to follow. Okay, number one is to make it in terms of y, or number one is to make the term similar to the ones that they have. So let's say, for example, in here, if I will make it in terms of a single term of y, so I will have it written as 2y. The first equation will be written as 2y is equivalent to 7 minus 3x. So your y is now equivalent to 7 minus 3x over 2. Okay? So this equation that you get will now automatically be substituted to equation number 2. So if you know that equation number 2 is equivalent to 9x times 9x plus 8 times the value of the y that you acquire is equivalent to 22. So we know that the y that we acquire is equivalent to 7 minus 3x over 2. So this would mean that we can automatically cancel out this particular value. And as soon as we cancel out this value, this will end up with this particular calculation. So this one will be 9x plus 4 times 7 minus 3x is equivalent to 22. Okay, so again, you're going to distribute these values here, which would give us 9x plus 28 minus 12x is equivalent to 22. All right. So from here, this is going to give us negative 3x is equivalent to 22 minus 28. So we know now that negative 3x is equivalent to negative 6, and cancel out the negative sign and solve for the value of x as equivalent to 2. Okay, so once we get the value of x, the procedure is just the same. We are now going to use the equation that we acquire here. All right, we are now going to use the equation that we acquire here so that we will be able to get the value of y. So your y now is equivalent to 7 minus 3 times the value of x, which is 2, over 2. So in here, we know that 7 minus 3 times 2, which is 6, is equivalent to 1. So this will now tell us that the value of y is equivalent to half. Okay, since the y is equivalent to half, then therefore we can now say that the solution is equivalent to x is equivalent to 2 and y is equivalent to half. All right. Okay, I hope you guys understand that. Now, what we are going to do now is I want you to try this and see your answer in the next video so that you will be able to see whether you fully understand this explanation or not. Okay, I'll be seeing you in the next video. That's it, and goodbye.